Let's now solve the great mystery of creating custom AOVs. Arbitrary output variables allow you to render any arbitrary shading network component into different images. But which ones do we need? Why do we need them? And what are light path expressions? There are a few ways to create AOVs in Katana, depending on the render plugin you are using. Arnold offers an Arnold Output Manager, which simplifies the creation of render output channels for Arnold, providing an Arnold-style view of filters, AOVs, outputs, and drivers. You can use the Arnold Output Manager together with existing Arnold Output Channel Define and Render Output Define nodes if you need to edit specific attributes of the outputs afterward. During this tutorial, we'll cover how to use the Output Manager provided by Arnold, create the main AOVs from scratch, and manually add them to the template to give an idea of the process. If you are familiar with LookDev and shaders, you likely already know which AOVs you want to render. But let's dive a little deeper with our Katana submarine into the AOVC. AOVs are created using light path expressions. LPEs describe the transport of light through the scene, starting from a source of light, bouncing between objects, and finally ending up at the camera. LPEs can be used to extract specific light contributions into separate built-in or custom AOVs, which can be output and recombined in various ways in a compositing package. LPEs are not particularly artist-friendly, so a list of built-in LPE AOVs is provided in the Arnold documentation. You can also find all the main LPEs in the Arnold Output Manager node. Let's bring it into the scene and start creating some AOVs. Each AOV usually consists of 3 components: the AOV itself, the associated driver, and the filter. At the top of the Output Manager, you can see the filters and the AOV list. In the middle, you can view the Output Channel box, which allows you to control which AOVs are outputted. At the bottom, you can see the drivers, which allow you to add an alternative output driver for each AOV. In the filter box, you can select a new filter name and type depending on your needs. In this case, we will keep the default one, which is RGBA filter. You can use a filter for each AOV, such as a diffuse filter, but for now, we'll use the same for all our AOVs. We can look at the list of AOVs and go through it to find all the LPEs we might need. Some might be missing. If we were in lighting, we would probably add specific custom light path expressions for each light. We would add a new custom AOV to give our lighters control over each light in compositing. We would use the specific light group syntax to isolate, say, the diffuse contribution from the HDRI Sky Dome cloudy light. We could do the same for any other light group and any other shader component contribution. In LookDev, we might not need that much control, and general AOVs could be sufficient. The first step is to hover over the plus sign below the Output Channel box, enter the channel name, scroll to the AOV needed, enter the path of the camera you want to render from, and choose the filter you entered in the filter dialog above. In this case, we'll leave it to the default, which is RGB filter, set to Gaussian. Choosing a pixel filter is very much a personal choice. Some people prefer one over the other, but ultimately, it's just slightly different amounts of blurring. More blurring means less aliasing, but it also comes at the cost of detail loss. We can add each AOV to the primary driver to create a multipass layer and have all our AOVs living under one multipass EXR. We can also create multiple drivers if we prefer that control and the ability to view each AOV in the Monitor tab. Let's enter diffuse for the name of the driver, which is our render output, and choose driver EXR as we want our renders to be in EXR. We could select JPEG or PNG in other cases, but EXRs allow us to include multiple layers in one image and hold much more information. Therefore, it is useful for us as we are adding all our layers to our primary driver. We could add denoising if we were in lighting, but I want to verify if my shaders are noisy, so I'll leave it to none. After setting up all the different render outputs in our AOV Output Manager, we can go back to our output channels and assign each AOV listed to the driver we created. We can test our work in the Monitor tab by triggering a live render. Next, we can open the Nuke Bridge to have a quick look at each of our passes. To get the Nuke Bridge up and running, you'll need Katana 4.5 or later, and Nuke 13.0 or later, a Nuke interactive and render license to run all three comping modes, a custom Nuke launcher script with a variable set to load the Katana Nuke plugin, and a Katana launcher script with a variable set to your version of Nuke. And it's quite simple to set up. I previously created and saved a Nuke script with my Katana launcher, where I set up a Katana reader and a Katana writer node. I added a gizmo to shuffle and control each AOV channel that I plan to render from my LookDev scene. The Katana reader will indicate to the Nuke Bridge at which point the rendered image from Katana should be going into the Nuke script, while the Katana writer node will indicate to the Nuke Bridge at what point the composite should be fed back into Katana. I will select the Nuke script that I previously set up to get connected to our scene. Select the live render running in the asset field below the Nuke input point, and click on Interactive Nuke, which will launch Nuke. There, we can view each AOV in the contact sheet and see how each pass is reacting to lights. We can also crank the exposure on our specular pass to see if it's too reflective. We can also create two different branches if we want to render only our character and don't necessarily need the color check assets. To do this, we can create a holdout using an Arnold object settings node. Just drag the path of your color check assets and select the parameters you need. Under Ray Flags, designate the path statement of the set as matte. This will create a holdout. You could also prune them off with a prune node if you don't want any contributions at all. At the bottom of each branch, we'll add a render node. This node takes a scene as input and render images. The first input is the scene to render, while additional inputs are dependency connection to track dependencies between passes. Each render node is a single invocation of Arnold and is used to track render settings, asset names, and which output passes are used. You can also use it for batch rendering. Just rename this node and use it in the batch render argument. Batch mode is super handy if you have a lot of frames to render, as it will render each individual file in the background. You can continue working on your Katana scene file while it's being batch rendered, since the command uses the last saved version. Let's show a quick overview of the process. Save your scene, open the command prompt, navigate to the directory where you have Katana installed using the cd command, then enter the following command to start a batch render and press enter. At this point, you will get all your renders in the setup directory. If we are creating our AOVs from scratch, the two nodes we need to output AOVs are the Arnold output channel define, specific to Arnold, and the render output define, which is not specific to any renderer. For RenderMan, you would use a PRMan output channel define, and for Redshift, the Redshift output channel define. If we look on the 3D light side, you will have access to the AOV manager through the DL settings node under Image Layers. Let's output the Beauty pass with all the AOVs built in. We'll name it Beauty and name the channel Beauty as well. For the light path expression, we will refer to our list of LPEs provided in the Arnold documentation. We can see that a beauty pass calls the camera event and contains all the AOVs, so our LPE is C.**. We will use the same name in the render output define. Setting your render locations to our relative paths pointing to your project directory facilitate the reuse of templates for future projects. We will also create other AOVs such as specular, diffuse, and emission. Each of these AOVs has its own light path expression, so we will change the naming and the light path expression in each node. Once all these AOVs are set up, we can create a macro for our artists to have faster control over toggling them on and off. After each Arnold output channel define and render output define belonging to the same AOV, we will add a switch node. On the group itself, we will edit the user parameters, add a number parameter, change the widget type to checkbox, and rename each parameter to match our AOVs. Look at this scene! What an excellent job we did, team! We've put a lot of effort into our scene, and now it's time to apply the finishing touches and wrap up our work. Our aim is to optimize the template for reuse by multiple artists, while adding the nodes we need for rendering. To accomplish this, we need to include a final render settings node. Within this node, we ensure to set the camera path, renderer, resolution, and any other parameters pertinent to our show or project. Now, it's time to review and test our work. Take a moment to step back and ensure that everything is properly in place and set up. Emis is now ready to start his career and enter production. Let's take a moment to wish him a happy show and many more opportunities to come. Now, it is your time to let your creativity flow and begin working on those assets. Don't hesitate to refer back to other Foundry tutorials or consult the Arnold documentation for more information on specific subjects. Happy look, dev peeps!